All right, welcome to week two. Hopefully everyone had a great weekend, and yeah, let's get started. So, announcements. So we will not be counting attendance for the first week. So that includes lecture one and discussion one because some new students joined the decal in the latter part of the week. So we didn't want to, count them on that. So just don't worry about attendance for the first week at all. But we are going to count attendance starting this week. So homework one is due this Friday at midnight. It should be pretty easy or manageable in some sort of way. So if if you need extra help, please utilize Ed or office hours. For discussion two this week, we'll be pivoting towards a more hands-on activity. So you'd be live coding or follow some sort of a follow along with us. So that's going to be pretty cool and fun. And we're going to release the next assignment, which is called Cow Finance, which is a mini project, and that's going to be released next Tuesday. And we recommend to start early, and please don't wait until the last minute to do so. And just a reminder that attendance cutoff time is 15 minutes after the respective lecture or discussion. And if you need or have any feedback, please let us know in the attendance form at the very end. Any questions about logistics or anything? Cool. So today we're going to talk about some more Swift features and key concepts, and then we're going to jump into building actual UI with SwiftUI. So the first kind of thing we're going to talk about Swift is this kind of feature called optionals. Next, we're going to talk about object-oriented programming, the differences between structs versus classes, some SwiftUI basics, and then I'm going to go ahead and create a demo of actually building a UI for you guys, and then we're just going to wrap it up with a quick summary. So jumping into optionals, let's talk about what we, I guess, experienced at the latter part of the last lecture, which is enumerations. So enumeration it declares a common type for a group of related values, and it's usually for constructs that can be represented by a list of cases. So for example, here we have these two enums, matter state, which represents these four states of matter, and direction, which represents these four directions. And so we can encapsulate these different cases into a single abstract entity, which is an enumeration. And so an optional is basically an enumeration with two cases. It has case sum with some wrapped value within it, and case none, which there is no wrapped value. So optionals are just enums. It either has a value or not. And we basically describe the not case with the keyword nil. So in Swift, nil is basically represents an absence of value. So in other languages, that might be null. In Python, I believe, and also Java, or Python is none, sorry. In Java, it's null. Okay, so that's nil. In Swift, nil is its, I guess, respective equivalency. So how do we create an optional? So this is syntax of how you create an optional. So here we have a variable called optional string one, and its data type is now optional string. So to denote that a variable is an optional type, we simply append the question mark after the data type. So string question mark. And we're assigning, in this case, we're initializing to a value of nil. So we're saying that this variable has a value of, it doesn't have a value. It's absence of a value. And then the second example, this is still valid. This is optional string 2. It's an optional string, but it's assigned to some value. In this case, this string. So to declare an optional, we use simply the question mark after its type. So here's an analogy or kind of make sure that you make sure you understand this in your head. So here we have this variable called optional int, and its type is an optional int. And it's declared as optional int because we have this question mark after its data type. And so when I print this out via the type method and pass in this variable, it prints out optional int like that. And so as you can see inside those brackets, you can see it's kind of wrapping that integer within this optional data type. So we can think of it as like a gift or a present. And so this gift is called optional int. And inside this present is the value contained within it. So currently, it has the value of nil. And that is what we call the wrapped value. Okay, the value inside of an optional is called the wrapped value. So here, let's try to add or initialize it to the value of 5. And let's try to add optional int plus 10. So if we print this out, we'll get an error. Oops. We'll get an error. And the error says value of optional int must be unwrapped to a value of int. So the reason why this fails is because we cannot add an optional int with a regular integer, right? So we need to somehow get access to the wrapped value within here and add it with 10. So here, for example, we have the optional int initialized to 5, and it's contained within this optional data type, right? It's within this, it's wrapped around this optional. And so somehow we need some mechanism to unwrap it to get it outside of this gift box. And once it is unwrapped, its data type is now the regular integer so that we can perform regular arithmetic operations on it. Is this concept so far clear? Any questions? Cool. So there are 3 main ways we could work with optionals. One of them is called optional binding. And what that means is that we conditionally bind the wrapped value of an optional to a new variable. So if there is some value to the optional, which is not nil, we conditionally assign it to a new variable that we can use of the regular data type. So here's an example. Here we have this variable called optional string, which is of optional string data type, and it's assigned to some value. In this case, the string hello world. And so the way we could get access to this wrapped value is via this optional binding syntax. It looks very much like a regular if-else statement, but the main difference is that the first condition has this let keyword. And we could see that it looks like a variable, an initializer. So here, what it's doing is that we're going to go to optional string and check to see if it's nil or not nil. If it's nil, that means there is no value. We jump to this else case and perform any kind of error handling, or maybe alert the user, hey, something went wrong, or something like that. If optional string has a value, in this case, which it is, since it's initialized to hello world, it unwraps the value out of the optional string and assigns it to this variable called unwrap string. And within this scope here, and within these curly brackets right here, within this context, you can use unwrap string as a regular string data type. So within here, these curly brackets, I could use unwrap string as a regular string. So I could append it, I can mutate it, I could print it out, and use what I need to use, whatever I need to use that string. Okay. The next kind of way to work with optionals is called optional chaining. And this is when you access properties or methods of an optional instance. So for example, here, this image path is a dictionary. And here within this dictionary, we're supplying a key. Now, how dictionary works again is that you supply a key and you get the corresponding value. So for example, in a real life dictionary, the key value pair analogy is that the key is the word itself and the value is its respective definition. So within here, I'm passing the key star into image paths, and I'm expecting some optional value that I'm getting out of it. So here on this, I also can use this has suffix method on this, the return value. And I'm basically saying, I'm assuming this returns an optional string or some sort. And I'm checking to see if this string has a suffix .png. And that's true, I'll print out this print statement. Now, since this is an optional, it returns an optional data type, I cannot immediately use has suffix on it because it could be nil, right? So if it's nil, the whole program will just crash. So in order to safely access its return value, I need to optionally chain it with this kind of question mark after it. So what this is saying is that, okay, try to access the value of image path star. If it is an nil, if it is nil, we basically abort and just get out of this if statement. If image path star returns some value, which means it's not nil, we basically continue onwards with accessing or calling has suffix on this string and continue forwards and check to see if it's true. Does that make sense? So here we're saying, is it nil? If it is nil, we'll just jump out of this if statement. If it's not nil, we continue to call hash suffix on it. Okay. The next way to do it is working with optionals is something called a nil coalescing operator. So what this operator does is applies a default value in case the optional instance is nil. So for example, here we have a dictionary, and this is how you declare and declare a dictionary in Swift. The key is a type string, and its value is type string. And this is an empty dictionary. And we have this string called default image path, which is of this string here. And then here we have a variable called heart path, and it's assigned to some value given to the right. So here, what we do is that we check to see if image path's heart, again, this returns a string. And again, accessing a value from a Swift dictionary returns a optional by default. So this returns an optional. So we need to check to see if it's nil or not. If it is nil, we basically go and return this value. So this is the default image path, which is not an optional. So this is a regular string, and we return this instead. But if image path's heart has some value, we just basically return this itself. Okay, so this allows us to basically specify a default value if the expression here on the left-hand side is an optional. Does it make sense? Okay. So another way you can work with optionals is something called a unconditional unwrapping, or aka force unwrapping. So if you're certain that an optional contains a value, you can force unwrap it using the exclamation mark. So here, for example, this is the same example that we had before. And here, instead of a question mark, we're saying, I don't care if this is optional or not. Again, this could return nil. It could return some value, but I don't care. Just give me the unwrapped value. Unwrap it for me. But again, with doing this, if this is nil, your program will crash because you can't call this method on something that's absent or is nil. So we suggest you not to use this unless, let's say, you declare something right before it and it has a value, and you could, you are 100% certain that whatever you're trying to unwrap is not nil. So another cool way, I guess, or unique way of working with optionals and in more kind of cool syntax is this guard statement. So it's used to transfer program control out of a scope or exits if one or more conditions aren't met. So let's take a look at this function here. This function is called transform. It takes two parameters, s and required min length. And what it's basically doing here, you can see that this is a guard statement. Oops, sorry. And what it's saying here is that, okay, we're going to check to see if this condition is true or false. So is the length of the string greater than or equal to the required minimum length that we specified here? If that is true, we continue onwards with the rest of the function and perform some kind of operation or manipulation or whatever. But if this is false, we jump into this else clause and return or exit out of this function. Okay. Now, in some contexts, you could use a break here. You could use a continue here. There are other clauses that you could do, but usually you just want to return out of the function or something because some requirement isn't satisfied. So again, just to recap, the guard statement needs a condition. If the condition is true, we continue onwards with the rest of the function. If this is false, we exit, or basically we call this else clause and return out of this function here. So this is again like a gate. It's like a gate where this requirement needs to be met. If it's met, we unlock you to go forwards. Else, if it's false, we'll keep you out, and we basically say, hey, you can't get in here. This is not valid. So this is a cool way of concisely writing an if-else statement. So you could rewrite the same thing using if else. If s.count is greater than or equal to required min length, we return. Else, we continue to do the rest of the stuff. But what's really cool about this is that you don't need to have this nested with the brackets or anything. You could just have everything inlined in one indent like that. Everything's lined up basically. So if you encounter yourself writing an if else and doing all those checks, maybe try using guard, and it will help write your code more elegantly. Questions? Are we good? All right. So that was optionals. Let's talk about object-oriented programming. Again, hopefully you have some experience with 61A or 61B. But if not, hopefully this kind of illustrates how we're going to work with data onwards with the rest of class. So what object-oriented programming is a programming paradigm that organizes code into objects, which encapsulates data and behavior. And what that allows us is for modularity, reusability, and easier maintenance and software development. So let's say I want to represent a person in code, right? What I can do is I can create 4 variables: name, age, occupation, favorite color, and I could assign those variables to values to represent one person. Now, let's say I want to do that for 100 people, right? Now, it kind of doesn't make sense for me to write 400 variables to represent these 4 properties of that person for 100 people, right? That is a lot of maintenance for me, and no, there's a lot of opportunities for errors to happen. So what I could do is that I can encapsulate these 4 properties of this person into one kind of encapsulation, in which we call a class or a struct, which we'll talk about the difference later. But in code, we could, group these entities together in some kind of abstract way. And so this is how you would do it in Swift. So to represent this person, I can encapsulate it with this new data type called person, which is a struct. Now you can think of this as like a blueprint. So if you think about construction, like building houses, for example, this struct person creates a blueprint, and it specifies what person this person is, right? What is a person? It has a name, age, occupation, favorite color, and maybe what can this person do? And so with this blueprint, I can create multiple kinds of persons, or I could create a person with a different name, I could create another person with a different age, and so forth. So I can create however many persons I want with this single data type, or this struct, or like blueprint. So again, this is like blueprint. And to create multiple objects of this person data type, it's called instantiating. So I can create a person called Kaylee. Her name is, her age is 35. Her occupation is singer. Her favorite color is purple. I can create a totally different type of person called Robert. Age, occupation, favorite color, which is totally different. So again, these are 2 different objects, and we're instantiating them from this person struct. So to do that, how do we do this? Well, we could use this constructor. So we could basically create a variable called Kaylee and then call the person constructor. So we could say a person and then followed by the basically kind of parameters. So we could basically set the name, age, occupation, favorite color, sort of like a function. So this is a unique kind of function. So just like that. And to access one of these properties, so a property is basically a variable within a struct or a class. So here to access this Kaylee's age, I use something called a dot notation. So I use Kaylee dot age. So you can think of this dot as like apostrophe in English. It's like a possessive. So I'm basically saying Kaylee, give me her age using this dot notation. It prints out 35. In other languages, you might heard of classes, and we'll get to that in a bit. Actually, we'll get into it right now. So let's talk about the difference between a struct versus a class in Swift. So this is how we declare, as we've seen, a person using a struct in Swift. So we encapsulate these data types. We have the struct keyword. This is its equivalency of creating this person in a class, with a class. And so the major difference is that one of its key requirements is that you need an initializer. So as you can see here, we have this required function, which is special, called initializer, and it has parameters name, age, occupation, favorite color, and you need to initialize all these properties before. So one of the main differences between a struct and a class is that a struct, it has a built-in initializer for you, so you need to write this out, but in a class, you have to do so. So both can define properties to store values, like we've seen. Both can define methods to provide functionality. So a method is simply a function within a struct or a class. What's really cool about that what's really cool about this bullet point is that you could define subscripts to provide access to values using subscript syntax. Again, this is not really, this is something cool. So you know how, for example, to access an element in an array, we use those brackets, right? Those brackets. We could do the same thing. We could write our own custom implementation within a struct or class where we could do, for example, Kaylee bracket and then enter something there to get something out of it. But again, this is just something cool. You can both define initializers to set up their initial state, and they can be extended to expand their functionality via protocols. Protocols in 61B is what we call interfaces, but don't worry if that doesn't make any sense. And conform to protocols to, again, to provide standard functionality of a certain kind. So classes, in addition, also have inheritance. So inheritance enables one class to inherit the capabilities and characteristics of another class. They also support typecasting. So let's say you want to cast a type of a class to a different type. You can also have deinitializers where, for example, if a class or the instance itself gets deinitialized in memory, you could specify some more rigorous behavior of what happens or some cleanup code. And again, one of the major differences of class and struct is that a class has more overhead. What I mean by that is that Swift it's less performant on classes because it uses something called reference counting. In Swift, the technology is called ARC, or automatic reference counting, in which it keeps track. It's a system of keeping track which objects are in memory. And if no other references this object, we could deallocate it. But don't worry if that doesn't make sense. It's just some internal kind of bookkeeping that Swift does that incurs more performant heavy systems. So in a sense, it's just less performant than a struct. So structs are more lightweight than a class. And so a reference counting is another technique of garbage collection. So you might have garbage collection Java, for example. So just another technique of doing so. So just to recap, structs have default member-wise initializers where classes don't. So classes, you need to provide an initializer. And the main kind of difference is what we call value semantics versus reference semantics. So when we assign a variable or some object to a new variable, or when we pass that object into a function, structs, that it gets copied. So when we're assigning a struct to a new variable, the value gets copied, or vice versa if we pass it to a function. But for classes, they conform to reference semantics. We're basically passing references around. So we're not copying at all. So you might, in other classes like C, for example, 61C, you might work with pointers. Well, Swift doesn't really have this concept of pointers. So there's no like direct pointers to an address in memory. So you don't need to think about that. So if you kind of think about references or addresses, you don't need to think about that at all. All right, so again, this is how we create a class in Swift. We have to supply initializer here. Again, it's required for a class, but is optional for a struct. All right, so let's talk about how the main difference between a struct and class, which is value versus reference semantics. So here I kind of hidden the declaration of a person away. And here we have, the same code with creating Kaylee here. And then here we have Kaylee2. We're creating a new variable called Kaylee2, and we're assigning Kaylee to it. And then on Kaylee2, we're changing Kaylee2's occupation to this, or initializing, or yeah, we're changing it to this value with the string count. So can someone tell me what will these two print statements be? So we're printing Kaylee's occupation and Kaylee2's occupation. So does anyone know what will happen here? Any brave souls? Yes. Yes, very good. Why is that the case?
Because we're working with a struct. Kaylee2 is a copy.
Very good. So since structs conform to value semantics, when we assigned or initialize a new variable to some struct, it gets copied. So right here, Kaylee2 gets a copy of Kaylee. So now that's why there's a difference there. So what about, again, this is the same exact code. What will happen here? Yes.
It would be accountant for both.
Very good. Why is that the case?
Because we made a class which references the class. So when you change it, the occupation, it also changes your name, which is the same class object.
Very good. So what we're doing here is passing a reference. And so when we do Kaylee2 equals Kaylee, Kaylee2 now points to the first Kaylee. So there's no copy being made. It just references back to Kaylee. So when we do Kaylee's to occupation, we're actually changing this object right here, right there. So let's take a look at this in a more graphical way. So this is structs. So when we do Kaylee2 equals Kaylee, and we're changing Kaylee2's occupation to be accountant, we're creating a new copy, and we're changing Kaylee2's, the copy's occupation to be accountant. Okay, so there's two separate objects. Now for classes, again, same thing here. We have Kaylee2 equals Kaylee, Kaylee2 the occupation equals accountant. But since Kaylee2 points to the original Kaylee, and when we do Kaylee2 the occupation equals accountant, we're actually changing this object's accountant, which both references. Alrighty, so that was the difference between structs versus classes. Any questions there? So what I recommend you do is that when you are creating your regular data types, use structs versus classes because they're more lightweight. Okay. There are some instances where you need classes. For example, the features I mentioned before, if you need inheritance or more robust features. And we'll also, in week 4, we'll talk about a kind of app architecture paradigm that requires us to use classes. Again, if you have questions, feel free to raise your hand. All right, let's get into it. So this is SwiftUI. So how do we build iOS apps? Again, we have Xcode, which is the IDE that we code in. We have Swift, which is a programming language, which basically describes the logic and how we could represent, create data to use. SwiftUI is a UI framework, and it's declarative. And what that means is that we simply state what your UI should do. And to create more complex UI, we could use something called composition, where we could use smaller pieces of UI and build them or combine them together to create more complex views. And what's really cool about SwiftUI is that it's cross-platform. So you can have a single code base that targets all of these 5 Apple platforms. So to create UI in iOS or native, to create UI for native iOS development, there are actually 2 ways to do so. You can use SwiftUI, which is the framework that we're going to learn this decal. But in the past, there was also something called UIKit. So when the iPhone was released in 2007, it didn't come with the App Store. The App Store came around 2008, 2009, and that's where iOS 2 was released. And iOS 2 is when Apple released, I guess, frameworks or APIs for developers to code. And that's when UIKit came about. So that's around 2008 or 2009. And so it's been there all the way until 2019, where SwiftUI was introduced. And that introduced a new paradigm, which we'll be using. So again, UIKit is still live today. Again, if you were to go to LinkedIn or job search for an iOS position, iOS developer, most of the company's code bases are still in UIKit. So right now, since it's been around 5-ish years since SwiftUI was introduced, most of the code base have some mix of SwiftUI and UIKit code. But majority of the apps that you see on the App Store with big companies, they're still using a lot of UIKit code. So the main difference is that UIKit is imperative. It's object-oriented. So what that means is that this is how you create a button in UIKit. You create an instance of UI button, you call the set title method on the button, you add it to this targets on this view controller where you can now press it. So it's a lot of this, that. So it's very methodical. Where in SwiftUI, okay, it's step by step. But in SwiftUI, it's declarative. Hey, I just want a button. Here's an action. This is what it looks like. That's it. Okay. So I think a really good analogy is that you go to a restaurant and UIKit is like, hey, can I have that bread on top of that shelf? And then I want to use that knife. And then I want to use that jar of peanut butter on that shelf. And then when you paste it on the bread, I want you to paste it diagonally. So it's very step by step. Whereas in SwiftUI, you go to a waiter is like, kind of a PB&J sandwich, please. Okay. Just tell it what you want. So the main core thing about SwiftUI that I want you to understand is that a view defines a piece of UI. So what is a view? So a view is basically some UI, right? So SwiftUI, Apple gives us some really fundamental views. So text, image, button, text field. Text field is how people can enter into a text box. There are different shapes I could use, round, rectangle, capsule, and many, many, many more. You can create more complex views via this thing called composition. So I can basically have a text right here, maybe add another text here, and put it in some sort of container so that they're aligned horizontally. So one good analogy I think will help you is that these views right here are like Lego bricks, right? Lego gives you some bricks that you could build with, and each brick has some unique features to it. Some brick has more whatever connectors on it. Some has weird shapes to it. And to build a structure with it, you basically, in different combinations, you basically put a brick on top of another brick, or you snap a piece to another piece, and that's how you create a more complex piece. So that's how SwiftUI works. So to basically create the composition behavior, we use something called stacks. And stacks are containers for composition. So let's say we have this text view right here, and I want to create another text view right beside along with it. To do that, I use something called an H stack. So an H stack is a container that aligns its subviews horizontally. Now, what if I want to align objects vertically? I could use a V stack like that. Now, what if I want to align objects? So we talked about the x-axis and we talked about the y-axis. What about the z-axis? So the axis that is pointing towards you and away from me, that's something called a z-stack. So it's like Photoshop layers if you worked in Photoshop before. Now, there's a concept called modifiers, which augments a view's behaviors and properties. So let's say we have this text right here, and this is how you create a text in SwiftUI. I could use something called view modifiers, modifiers that modify a view, and attach it to a specific view like this. So right now I'm saying this text hello, its foreground style, which is its text color, would be of color blue, and I want to make it bold, just like that. Alrighty, so let's get to our demo. Any questions so far about SwiftUI? Okay. So in the quick 15 minutes or so, we will build this UI right here. This is the UI of the GitHub iOS mobile application, and this is its repository. You can search up Swift, and this is the header of what it looks like. And we're going to build it from scratch. You can follow along if you want, but if not, just feel free to enjoy. And yeah, so this is the view that we want to build. Okay. All right, I'm going to boot up Xcode, and this is what it looks like from the get-go. So as you can see here, this is our file here in the center. And right now we can see that it's importing the library SwiftUI. It has this struct called content view, which conforms to this view protocol. So what we're saying is that this content view is a view. And one of the requirements of this protocol is that it needs to have this variable, this property called body of type sum view. Okay, so this sum view, you don't need to worry about it. What it does internally is create the data type for whatever you put in. Because within here, I could put an image, I could put a text, I could put a VStack, I could put a lot of things in here, right? And internally, it computes the data type so that SwiftUI can handle it. So you don't worry about it, just something, it's just syntax that you need to do. Okay. So within this body is where the actual UI is going to happen. Okay. And then down here is something called SwiftUI previews. This preview macro right here, and within here is basically what we want to display in our SwiftUI canvas. So the SwiftUI canvas is a unique kind of feature in Xcode where you could see whatever you display here live. So we're gonna Let it boot up a little bit. Should give it a second. There we go. So you could see here that this is rendering what we have displayed here, which is content view. And what is content view? What is its UI? It's specified right here. Okay. So as you can see here, we have a VStack. And within this VStack, we have this image right here, and we have this text. So you can see here, we have this image right here, and we have this text underneath. And we add some padding around it, around the whole VStack like that. Okay. So what's really cool is that SwiftUI previews can update live. So down here, you can see that we have 3 buttons. The most left button is the live mode. So what I could do here is that I can edit. So I could say, hello, Cubstart decal. You could see it updates live for you. Okay, so I could change things here. It will reflect in the simulator live. The middle button is the inspect, kind of the, I don't know what's called, like the item selection view, or it's just a static view of what you have. So you could basically, for example, select items within here, and it will highlight the corresponding code in the file right here. So I can edit this, it's like that. Here is on the third button right here, you can see that we have color scheme variants. So again, by default, SwiftUI supports light and dark mode. So you can see what your app looks like in dark mode, like so. What if you want to take a look at your app in different orientation variants? So let's take a look at what our app looks like in horizontal, and by default, it's portraits. And let's take a look at our app at different text sizes. So for example, here is a whole grid of different text sizes. So maybe the user in settings, slides the slider all the way to the right to maximize their text. Again, by default, a regular SwiftUI text has all these features supported. So you can take a look at all these. And so here you can also target or show what device you want to be displayed. So you want to do an iPad or a specific iPhone version, you could do that as well. So that is a quick look at SwiftUI previews over here. Okay. Now let's get to it by actually building the UI itself. So how I like to kind of build UI is kind of think about what kind of rectangles or what kind of things I could group together, use some sort of variable, or, for example, this right here sort of, is like a rectangle that I could isolate. This maybe section here I can isolate together as a VStack. And then here is HStack because I can see these 2 elements right there. So when you look at a UI, you got to think about, okay, what are the bigger picture and then what is inside those containers, if that makes sense. Okay. So again, there's many ways to do this, but let's go ahead and create the logo that we have here, right? So don't worry about the rest of this. Let's just take a look at this image and this Swift Lang text right here. Now, to import assets into your project, you could see that we have this assets file right here, and you could drag and drop any assets or images into here. So I've dragged this image and I named it swift.og, a dash OG, and I could reference it. So within here, I will, Within here, to create the image, I will use the image view, and I can just basically specify the image using swift.og. And so let's take a look at what it renders. So you can see it kind of carelessly fills up the whole iPhone. Now, I want to make it resizable, okay? So due to that, I use the resizable view modifier to make it resizable. So now it's kind of resizing it to fit the frame of the device screen. And I want to specify a certain width and height of this image. So to do so, I can use the frame view modifier. And you can see I can specify the width, height, and alignment. Now, what's really cool about Xcode is that if I want to target only the width and height parameters, what I could do is I could just simply write W, and you can see that it selects the W, the width right here. And if I want the height, I just type in H, and it selects the H. And then all I do, I just click enter, and it fills the thing for me. Okay. So for width and height, I think height of 25 points and width of 25 points look great. So here you can see that now it kind of shrunken down to exactly what I want here. So how do I put this Swift lang text next to this image? What do I do? What do I do next? Sorry? An HStack, very good. So what I could do is I could use HStack, put this within the HStack like this, put the image within the HStack. Oops. Why is it not cutting it for me? There we go. All right, like that. And then what do I do here? What's next? What view should this be? So this should be a text. It's just regular text. So this is Swift lang. So let me zoom this in so you can see a bit better. All right, so you can see this is a bit of grayish color. So to change its color, I use this foreground style view modifier. And I simply use this, I'll put it with this gray color. And then to set its fonts, I could use one of the system default fonts like title, title 2, large title, caption, or I could set a custom font that scales with the system. So sys.system size, and I specify 17. Okay. So that's how we will create the top heading right here. Okay. Any questions so far? Does this make sense? Okay. Now let's create the main view with the Swift and the .Swift programming language and the link itself. So this is what I call the main view. Okay. What's the first step? What's the first step I should do next? So the first step is, since everything is aligned vertically, what containers should I do the whole thing in? Sorry? So I should contain everything within the VStack because, again, everything kind of lines vertically, right? So again, right now we just did this thing right here. Next, we'll do this thing. Okay, so I'm lining these two containers vertically. So I'll just put this within the VStack. And then again, this thing right here, what stack should everything inside here be in? A VStack. Very good. So I can isolate these three different major views. I could do this text Swift. I have this another text, the Swift programming language, and I have this another kind of, what should this be right here? An HStack. Very good. So what we could do is that I could do text.swift. Now to make a text bold, I could use the .bold view modifier. And then the font, I'll use the regular system title like that. Now for the next is the Swift programming language. And here we'll just have it like that, right? So now what's next is this view right here, which has the symbol link and this text swift.org. So what I could do is I could use this HStack. Now, one really cool thing about these symbols is that Apple provides an app called SF Symbols that you could download from the website. So SF Symbols is a Mac OS app that contains all of Apple's custom crafted symbols. So you could browse around. These are all the symbols that you could use within your app. So you don't need to create your own custom symbols. So I want a link, and this is the link that I want, this symbol right here. So I could right click on it. I can use copy name. And then within here, I could, to add it within to my view, it's simply an image. So I use image and I use the system name variant. And I basically, the name of the symbol, which is a link. And there it goes. It shows up right there. Okay. Now, you can see here in the UI, it's grayed out. So what we could do here is that we could use this foreground style again with the dark gray. And then the text, we'll have it as swift.org. Okay. Now, I want both of these images and text to have the font weight of medium. So font weight, I can use bold, black, but I want it to be medium. So I do this, and I just copy this again to reflect it on the text as well. But what's interesting is that you can see we have some duplication here. And one thing that we could make this much simpler is that we could move this font weight view modifier outside of each individual subviews and apply it on the H stack. And what this does is that it applies this view modifier on the image and also on the text. Okay. So if you see you're using repeated view modifiers within some subview or within the container, you just bring it out and apply it onto the container. And SwiftUI will apply that view modifier on each of the container's subviews. So now we have something, but it's looking a bit different, right? Everything is in the center. Everything is aligned in the center. So what we want to do is align it to the left. So what we could do is that on the V stack, which is holding everything, a V stack, you could also specify the alignment spacing here. So we could use the alignment, and what I could have is center, leading, trailing. And we're going to use leading. Now, the reason why it's not left and right is because some devices, if the user enabled for some languages, for example, Arabic or Hebrew, they're read from right to left. So leading corresponds to the first direction of the language. So in this case, it's English, so it's from left. So leading is left here. But in Hebrew or Arabic, the leading would be right. Okay, so it's language agnostic. Let's say that. So if I do trailing instead over here, it's going to shift everything to the right. Alrighty. So now it's getting a bit more convoluted here. Okay, I don't know. I don't know. I don't really know what's going on right here because there's a lot of code going on, right? It's kind of confusing. So what I could do is I can create variables. So I could extract this into its own variable. So within the content view struct right here, after the body, I could just make a variable since it's a struct, right? So I could say this is my header view. And it's a type sum view. And I could simply paste that in and use it as a variable like that. So nothing happened, the same thing, but I just refactored the code so that looks much better. So I could use the same thing here as well. I'm going to call this the main view. And then now the issue here is that SwiftUI can't, if you put your stuff into this variable, you need some container to wrap it within everything. So to do this, I could use a VStack to wrap everything with it, or I could use something called, I could annotate this as a view builder, in which SwiftUI basically will figure it out for me. So for example, in future lessons, you could introduce an if statement here to say, hey, if something is true, we'll show everything here. And this view builder will basically, it helps us resolve this issue just like that. Okay. So if you don't want to use a container or something like vstack or hstack, you just annotate the variable with an @viewbuilder, and it will just do it. It will handle everything for us. And then we'll use this main view right here. And now just really quickly, I'll just create this button right here, this star button. So what I could do here is that after everything, to create a button, you do this syntax. So you specify an action right here. And then after these curly brackets is what the button looks like. And this button, again, I'll just basically type in what it looks like here. So it has a spacing of 3. It has a spacer. Okay. I am going to just create the image first here. Star. We're gonna have text star. On this H stack, we'll have a foreground font weight of medium. And then padding of 15. Foreground style of black. Sorry, I'll be really just in a minute. And then here we have this background of white. So you can see that we have this star right here. And then here, oh, this should be font weight. And then here, to make this kind of border, this border outline, what I could do is that I could wrap or overlay this shape right here with an overlay. And then here I could use something called a shape called rounded rectangle. Hi. Okay, got it. Sounds good. All right, no worries. All right, so we'll continue onwards next class.